The Supermarine Spitfire, a fighter that defined World War II. Fast, maneuverable, and a literal nightmare for enemy pilots. But what if it had a successor that made it look slow? What if British engineers had built something even better? Something designed to dominate the skies with raw speed and power. That was the idea behind the Supermarine Spiteful. It wasn't just another version of the Spitfire, it was built to replace it. A brand new design with stronger construction, a more powerful Griffon engine, and a completely reworked wing. At the heart of the Spiteful was its laminar-flow wing, a cutting-edge design meant to reduce drag and push speeds higher than ever before. On paper, it seemed like the perfect next step, but war doesn't happen on paper. By the time the Spiteful was ready, the world had changed. Faster jet-powered aircraft were already taking shape, and traditional propeller-driven fighters were becoming outdated. Still, the Spiteful had potential. It was one of the fastest piston-engine planes ever built. But instead of becoming Britain's next great warplane, it was quietly forgotten. So what happened? Was the Spiteful simply too late to make an impact? Did its supposedly advanced wing design turn out to be a problem rather than an advantage? Or was this plane flawed from the start, doomed no matter what? This is the story of the Spiteful, the plane that should have been the future but never got the chance. Now, when it comes to flight, wings are one of the craziest yet important components of an aircraft. They generate lift, determine stability, and influence speed, making their design a complex balance of aerodynamics, efficiency, and practicality. Over the years, aviation engineers have developed a variety of wing shapes, each serving a distinct purpose based on an aircraft's role, performance needs, and budget constraints. Aircraft wings come in a shocking range of shapes and configurations. Some are long and slender, optimized for endurance and efficiency, while others are a bit shorter and broader, designed for maneuverability and stability. From swept-back wings seen on supersonic jets to the triangular delta wings used in high-speed aircraft, the variations are nearly endless. The shape of a wing is dictated by multiple factors, like cost, structural feasibility, and the specific aerodynamic goals of a given aircraft. For instance, simple rectangular wings are often favored for training and civilian aircraft. They're cost-effective, easier to manufacture, and provide stable, predictable flight characteristics. Their design ensures uniform lift distribution and gentle stall behavior, making them ideal for beginner pilots. However, the drawback is their increased drag at higher speeds, limiting their efficiency in faster aircraft. Now, on the other end of the spectrum, elliptical wings represent one of the more aerodynamically efficient designs, theoretically minimizing induced drag. The most famous example of this wing is found in the legendary Supermarine Spitfire, a British fighter plane that gained notoriety during World War II. Now, while visually striking, the Spitfire's elliptical wings were not without their drawbacks. True elliptical wings, without modifications, tend to have poor stall characteristics, often making them unpredictable in certain flight conditions. Additionally, their complex shape made them more difficult and expensive to manufacture compared to conventional wing designs. To counteract the stall issue, the Spitfire's design introduced a subtle twist to the trailing edge of the wing, improving flight stability, but slightly increasing drag, somewhat undermining the very reason for choosing an elliptical shape in the first place. Now, as the war progressed and aircraft technology advanced, modifications to the Spitfire's wings became necessary. One notable adaptation was the introduction of clipped wings, which reduced the wingspan by over a meter. Though this altered the aircraft's signature shape, it significantly improved roll rate and maneuverability, giving pilots a critical edge in a dogfight. Surprisingly, the clipped wing design also slightly increased the plane's top speed due to reduced drag and weight. As speeds continued to increase, the original elliptical wing structure showed its limitations. Higher aerodynamic forces made the Spitfire's wings more susceptible to twisting and structural stress. Later models required reinforced wings made of stronger materials, ultimately leading to a less elliptical design that prioritized durability over aesthetics. Despite the adaptations, the limitations of the Spitfire's wings were becoming apparent, prompting the development of an entirely new wing concept, which led to the Supermarine Spiteful, a successor to the Spitfire designed to address the shortcomings of its predecessor. So, as the Spitfire evolved, its wings underwent a redesign, incorporating stronger metal and a less pronounced elliptical shape. However, while the Spitfire's engineers were refining its existing design, Supermarine was already working on a radically different solution, one that aimed not only to correct the wing issues, but also to deliver a significant boost in high-speed capability. The result was the Supermarine Spiteful, a fighter that was built to surpass its predecessor in agility and raw speed. By 1942, British aviation experts were looking for ways to enhance roll rate and aerodynamic efficiency. The Air Ministry tasked Supermarine with developing a new wing that incorporated cutting-edge aerodynamic principles. One key focus was the implementation of laminar-flow wing technology, a relatively new concept at the time. The idea behind laminar flow was simple, yet quite revolutionary. designed the wing in a way that allows air to flow over it as smoothly as possible for as long as possible, reducing drag and improving overall performance. In an ideal scenario, a laminar flow wing would have a teardrop-shaped cross-section, delaying the point at which airflow became turbulent and thus maintaining higher efficiency in flight. To maximize the benefits of this technology, Supermarine engineers had to ensure an exceptionally smooth wing surface. Any irregularities, like rivets, panel gaps, or imperfections, could disrupt the airflow and negate the advantages of laminar flow. This level of precision manufacturing was challenging, but the potential gains were too significant to ignore. By mid to late 1942, Supermarine's chief designer, Joseph Smith, led the development of this groundbreaking wing. By November of that year, they finalized a design that bore little resemblance to the Spitfire's iconic elliptical wings. Instead, it featured a more conventional straight-edge shape with a taper, resembling the wings of emerging high-speed fighters. With an estimated wingspan of approximately 11 meters, it was shorter than the Spitfire's wings by nearly half a meter. Additionally, the new wing design reduced the overall wing area by about 2.5 square meters, contributing to a really great weight reduction of about 200 pounds. This weight saving, combined with a streamlined aerodynamic profile, was projected to deliver an increase in top speed of approximately 55 miles an hour. To put it into perspective, Spitfires from the early 40s could max out at 410 to maybe 420 miles an hour. But now they could potentially push past 460 miles an hour with this new design. Given Supermarine's established credibility, these numbers were taken seriously. When the company presented its findings to the Air Ministry in late 1942 or 43, the response was overwhelmingly positive. The performance potential of this next-generation fighter was undeniable, prompting the Air Ministry to issue specification F-143, officially commissioning the development of a new laminar flow wing aircraft. By February of 1943, the British Air Ministry had finalized its decision and issued an official specification. However, rather than commissioning an entirely new aircraft, the initial directive focused solely on modifying the existing Spitfire. This modification primarily revolved around the introduction of a newly designed wing and an upgraded propeller system. Internally, Supermarine designated this project as Type 371, strictly pertaining to the wing redesign and the propeller enhancements, leaving the rest of the aircraft largely unchanged. The government's plan was straightforward. Supermarine was to construct 3 prototypes, each based on the Spitfire Mark 8 airframe but retrofitted with new wings. Additionally, the aircraft would feature a revised propeller configuration. This modification included contra-rotating propellers, an innovation intended to counteract the increased torque that would accompany the anticipated rise in engine power. Higher speeds demanded stronger engines, and stronger engines produced more torque, which could be destabilizing. The dual rotating propellers help mitigate this issue by counterbalancing rotational forces. Although specific documentation on why this feature was requested remains scarce, it was likely introduced as a precautionary measure to ensure stability at higher speeds. Supermarine had some flexibility in their choice of power plant. They were permitted to equip the prototypes with either the widely used Rolls-Royce Merlin engine or the newer, more powerful Rolls-Royce Griffon engine. At the time, the bulk of Spitfire production was still focused on Merlin-powered models, but there were already concrete plans to transition toward mass-producing Griffon-powered variants. The goal was pretty clear. If the new wing design demonstrated significant improvements in performance, it eventually could be integrated into Spitfire production lines, gradually replacing the elliptical wings with more aerodynamically advanced laminar flow wings. Additionally, Supermarine had to ensure that this new wing design would be compatible with the upcoming Spitfire Mark 21, a model that was being developed with powerful Griffon engines in mind. The first prototype of the Mark 21 was set to take flight in mid-1943. Furthermore, there were additional minor requests from the Air Ministry. They wanted new wings to have a folding mechanism for potential use on aircraft carriers, and they sought slight improvements in the pilot's field of vision from the cockpit, which had been a long-standing issue with earlier Spitfire models. When Supermarine signed the contract for prototype development in early 1943, they were expected to have a functional aircraft within approximately 8 months, with a target completion date around October of that year. But by the deadline, the project was far from ready. In fact, not only had they failed to build a prototype, but they had yet to even produce a full-scale mock-up of the aircraft. But the delays weren't due to a lack of effort. Supermarine was simply stretched too thin. At the time, they were fully occupied with ramping up production of standard Spitfires, leaving very few resources available for the Type 371 project. Moreover, the development of laminar flow wings required an exceptionally high level of precision in both engineering and manufacturing. This type of wing had to be constructed with exacting standards to achieve its intended aerodynamic benefits. And with most of Supermarine's experienced engineers focused elsewhere, progress was painfully slow. In addition to requiring precision, the manufacturing process for these wings was significantly more complex, meaning even under ideal conditions, they would have taken much longer to develop than traditional elliptical wings. With the project stalling, the Air Ministry decided to revise their initial prototype request. Instead of 3 aircraft with different configurations, they reduced the requirement to just 2 prototypes fitted with Griffon engines and contra-rotating propellers, while the third would retain the Merlin engine and a standard propeller. This change indicated a shift in priorities rather than merely testing the new wing design. The British government was now particularly interested in exploring the potential of Griffon-powered Spitfires with advanced aerodynamics, setting the stage for what would become one of the most ambitious fighter aircraft experiments of all of World War II. As development progressed, the project finally received a distinct identity separate from the Spitfire. Initially dubbed the Supermarine Victor, the aircraft underwent multiple name changes in quick succession. By March of 1944, when the mock-up design was formally evaluated, it had been rebranded as the Valiant. However, the name didn't last long either, as it was soon replaced with the Spiteful, a title that would more fittingly reflect the aircraft's aggressive, high-performance aspirations. With the name changes came an important realization. The assumption that the new wing design could simply be integrated into the Spitfire frame was flawed. Aircraft engineering is not as simple as swapping out parts like pieces of a puzzle. Each modification demands structural adjustments to maintain balance, aerodynamics, and performance. The Spitfire's signature elliptical wings weren't just for looks, they were deeply integrated into the aircraft's design. Replacing them with a new laminar-flow wing would require significant modifications to the fuselage. At that point, it no longer made sense to call the aircraft a Spitfire. It was becoming something entirely different. This shift in approach further delayed the project. Developing an entirely new fuselage to accommodate the redesigned wings added to Supermarine's already overwhelming workload. But after months of effort, on June 30th of 1944, the first prototype of the Spiteful family finally took flight, or at least a makeshift version of it did. Now, under immense pressure to get results, Supermarine opted for a shortcut. Instead of waiting for a fully assembled Spiteful airframe, they took a Griffon-powered Spitfire Mark 14, stripped off its elliptical wings, and retrofitted it with a new high-speed laminar-flow wing set. Now, while impractical for mass production, this decision did serve a crucial purpose. It provided an immediate comparison. Since the Mark 14 and this modified prototype were nearly identical aside from the wings, the engineers could isolate exactly how much performance was gained from the new design. And the results were promising, though not as groundbreaking as expected. With sleek, low-drag wings, the modified Spitfire turned Spiteful outperformed its predecessor in terms of top speed. But how much faster? Well, exact numbers remain elusive, but educated estimates can be made. The Spitfire Mark 14 had a top speed of 440 miles an hour at 25,000 feet. The Supermarine predicted a potential 55-mile-an-hour boost from the new wing design. So if everything went perfectly, the Spiteful's prototype should have been pushing about 495 miles an hour. However, test pilots quickly noted that while the speed improvement was significant, it didn't quite meet the optimistic projections. If the actual increase was about 30 miles an hour instead of 55, that would still place its estimated top speed closer to 470. It's still impressive, but falling short of expectations. But top speed wasn't the biggest concern. A more pressing issue quickly emerged. The Spiteful stall characteristics were alarmingly poor. While speed is crucial in combat, an aircraft that becomes unpredictable at low speeds, or worse, one that enters a stall too easily, poses a big danger to pilots. This unexpected flaw meant that despite the aircraft's potential, the design team now had an entirely new challenge to solve before the Spiteful could be considered a viable successor to the Spitfire. When it comes to aircraft performance, stall behavior is a critical factor in determining how safe and predictable a plane is to fly. Ideally, when a plane stalls, the airflow over the wing should break first at the root, where the wings connect to the fuselage. This allows the aircraft to retain some control, making recovery easier. However, if the stall starts at the wingtips, it can cause violent rolling motions that are sudden and difficult to counteract, especially at low altitudes where there's little time to react. The Spitfire's elliptical wings have a slight twist along the trailing edge, a subtle but deliberate design choice meant to prevent wingtip stalls. This feature ensures that airflow disruption started at the wing roots first, keeping the aircraft more stable during a stall. However, the Spiteful, despite not sharing the elliptical wing design, unexpectedly suffered from dangerous wingtip stalls. This problem would require serious attention in later models, but the initial prototype never had the chance to receive those fixes. On September 13th of 1944, tragedy struck during a mock dogfight between the Spiteful prototype and the Spitfire Mark 14. While maneuvering, the Spiteful abruptly flipped upside down at a low altitude. The pilot, Frank Furlong, was unable to regain control, and the aircraft crashed, taking his life. The exact cause of the crash remains uncertain. However, later investigations suggested that the ailerons may have locked up mid-maneuver, effectively freezing the pilot's control over the roll of the aircraft. With so little altitude to recover, Furlong had no chance of escape. The loss of the prototype left Supermarine without a test aircraft, yet they didn't seem to be rushed to build a replacement. Work was already underway on a second Spiteful, which featured an entirely new fuselage designed specifically for the aircraft rather than being adapted from the Spitfire. However, progress was slow, and by the end of 1944, the second prototype was still not airworthy. It wasn't until January 8th of 1945, just a few days into the new year, that a second Spiteful finally took to the skies. This second prototype, often considered the first true Spiteful, had dimensions that differed from the Spitfire. Measuring 10.03 meters in length, 11 meters in wingspan, and standing 4.09 meters tall, it still bore a resemblance to late-model Spitfires, particularly due to its bubble-style canopy, which improved pilot visibility. However, its fuselage had a more pronounced curvature, making it stand out from its predecessor. The most notable changes, however, were in its wing structure and landing gear. One key improvement addressed a long-standing issue with the Spitfire's landing gear. On earlier Spitfire models, the landing gear retracted inward toward the fuselage, making the stance relatively narrow. This created challenges for pilots during takeoff and landing, and the narrow base made the aircraft more prone to tipping. The Spiteful corrected this by reversing the landing gear's retraction direction, now extending outward toward the wingtips. This provided a much wider and more stable stance, making landing significantly safer. But beyond structural modifications, the Spiteful also boasted enhanced armament and increased fuel capacity. While the Spitfire Mark 14 was equipped with two 20mm cannons and two 303 machine guns, the Spiteful upgraded to a more powerful configuration. 4 20mm cannons. Fuel storage was another area of improvement, with internal capacity increased from approximately 110 gallons on the Spitfire to 140 on the Spiteful. This boost extended the aircraft's operational range from 460 miles to 564, giving it greater endurance in combat scenarios. Another major shift in the Spiteful's development was the complete abandonment of the Merlin engine. While earlier versions of the project had left room for the possibility of using the Merlin, it quickly became apparent that the engine simply wasn't powerful enough to keep up with evolving performance demands. As a result, the Griffon engine became the sole power plant for the Spiteful, ensuring it had the raw horsepower necessary to compete with the next generation of fighter aircraft. With these modifications, the Spiteful was shaping up to be a formidable machine. But even with all of its improvements, challenges still lay ahead. Would these upgrades be enough to make it a worthy successor to a legendary Spitfire, or would its issues prove too great to overcome? With the introduction of the second prototype, the Supermarine Spiteful underwent further testing, flown by experienced pilots like Jeffrey Quill and Patrick Shea Simmons. Their assessments revealed a mixed bag of results. At high altitudes and top speeds, the Spiteful displayed superior performance compared to the Spitfire. However, at lower speeds, especially in takeoff and landing, it became difficult to control due to its unresolved stall issues. This made it an unreliable aircraft in certain crucial situations, something that would prove to be a major flaw. But despite its aerodynamic advantages, the Spiteful's performance was heavily dependent on maintaining the integrity of its laminar-flow wings. During trials, it was found that the aircraft could reach a top speed of 483 miles an hour at 21,000 feet and 409 miles an hour at sea level. Figures that seem promising. However, even the slightest imperfection on the wings, be it from rain, dirt, or even small insects, could disrupt airflow, leading to an immediate increase in drag and a significant drop in speed. That sensitivity posed a major challenge. Wartime aircraft had to be rugged, and any design requiring meticulous wing maintenance was simply impractical for mass production. Even small scratches could cause performance degradation, making the Spiteful one of the more high-maintenance aircraft designs of its time. But despite these concerns, the British Air Ministry did see potential in the Spiteful and placed an order for 650 units in January of 1945. At this stage, modifications were introduced, including an enlarged tail section to improve stability and control. While this adjustment helped refine the handling somewhat, the core issue of stall characteristics remained unsolved. As the war in Europe neared its end, the need for new piston engine fighters diminished. One by one, Spiteful orders were quietly canceled, particularly after Germany's surrender in May of 1945. Testing of the Spiteful continued into the post-war years, but it was already fighting a losing battle. Even with an improved production model reaching 494 miles an hour, it couldn't compete with the emerging era of jet-powered fighters. Britain's military, like the rest of the world, was rapidly shifting toward jet propulsion, and propeller-driven aircraft were losing relevance by the day. One last attempt was made to salvage the Spiteful by adapting it for carrier-based operations under the name Supermarine Seafang. In theory, the Seafang could serve as a stopgap naval fighter until jets became practical for carrier use. However, it faced the same problems as its land-based counterpart, including poor low-speed handling. Established naval aircraft like the Supermarine Spiteful were already performing well, leaving little reason to invest in an unproven and problematic design. By 1948, both the Spiteful and Seafang programs were effectively dead. Only 19 Spitefuls and 18 Seafangs were ever built, and all were eventually scrapped. The project had become obsolete before it could even really see combat service. However, the Spiteful story didn't entirely end in failure. In 1944, the British Air Ministry issued specification E.1/44, calling for a jet-powered fighter with a laminar-flow wing. Supermarine took this opportunity to repurpose elements of the Spiteful into a new design, the Supermarine Attacker. The Attacker's wings were, in essence, direct copies of the Spiteful's. Unlike its predecessor, though, the Attacker actually made it to service, becoming the Royal Navy's first jet fighter in 1950. However, its career was neither long nor particularly eventful. By 1954, it was retired, having never seen combat. The Spiteful was a fascinating attempt at modernizing the Spitfire, but it arrived too late with too many flaws. As aviation rapidly evolved, it became just another footnote in history. A machine designed for a war that had already ended, rendered obsolete before it had a chance to really prove itself. The Attacker remained in service for a short period after its initial deployment, primarily within the naval reserves. However, its career did extend beyond British shores when Pakistan acquired a small fleet of Attacker aircraft, using them actively until at least 1958, with some reports suggesting their operation until 1964. But despite this brief second life, the Attacker was already becoming obsolete by the time it entered service, unable to compete with rapidly advancing jet technology. The saga of the Spiteful and its derivative aircraft ultimately highlight a hard lesson in military aviation. Sometimes pursuing absolute precision can become a liability rather than an advantage. While the Spiteful's laminar flow wing was an innovative concept designed to minimize drag and maximize speed, it also was its greatest weakness. The design required an almost pristine surface to function effectively. But as we said, in the real world, perfection is fleeting. Even the smallest blemishes, whether from rain, dirt, or insects, disrupted airflow and negated the aerodynamic benefits of the advanced wing. But these challenges weren't just theoretical even. Crazily enough, they were exacerbated by the realities of wartime production. Factories in the 40s were under immense pressure to mass-produce aircraft quickly, and achieving a near-flawless wing finish required for optimal performance was simply unrealistic. Every plane that rolled off the production line would have minor imperfections, making it impossible to guarantee that each Spiteful could live up to its intended performance metrics. Mass-producing an aircraft that needed near-perfect conditions to function properly was a logistical nightmare. The Spiteful was undeniably one of the fastest piston engine aircraft ever built, pushing the boundaries of what was possible for propeller-driven fighters. But there's a difference between building an impressive prototype and successfully fielding an aircraft in combat conditions. The RAF had to ask itself a tough question. Was it worth investing in a high-maintenance aircraft that demanded near-impossible production standards? The answer became increasingly clear as the war ended and jet fighters took center stage. By 1948, both the Spiteful and its naval counterpart, the Supermarine Seafang, were deemed obsolete. Production was officially halted, and only a handful of each model were ever built before getting scrapped. Ironically, the Spiteful's DNA lived on in the Attacker, Supermarine's first jet fighter. The Attacker borrowed the Spiteful's laminar flow wings almost directly, but unlike its predecessor, it was adopted for operational use. However, its career was short-lived and uneventful, never seeing combat before being phased out in favor of superior jet aircraft. Its performance was considered underwhelming compared to other early jets, and it quickly became apparent that its outdated airframe, originally designed for a propeller-driven plane, was holding it back. Now, while the Spiteful and its offshoots ultimately faded into obscurity, their story serves as a valuable case study in aviation history. It reminds us of the reality that groundbreaking innovation isn't always practical. The pursuit of cutting-edge technology is important, but if a design can't be reliably mass-produced, it becomes little more than an engineering experiment. The Spiteful was an aircraft that, in theory, should have dominated the skies, but in reality, it was a plane that asked for too much and arrived at a time when its kind was already on the way out.